STAT1150, 5-number summary, box plots, and outliers. A good place to follow up after numerical summaries, namely means and medians and standard deviations. But the focus now is going to come in on, or at least turn to something we call the 5-number summary, which leads into a box plot, which leads into naturally a narrative about outliers. Again, what are outliers? I defined them in a previous video, but again, they are an unusually high or low observation. And one of the things I'll teach you in this video is how to find an outlier. So a quartile, as we've seen before, is just a measure of location. So we have 3 quartiles. You think about if we had a piece of string, for example, and we're holding the string and out, and we have it stretched out. If we wanted to cut the string into 4 equal pieces, hence the prefix of quartiles, we would have to make 3 cuts, right? Well, these 3 cuts are denoted by Q1, Q2, Q3, or the first quartile, the second quartile, which is also called the median, and the third quartile. So each of these divide our group into approximately 25% in each group. So the first quartile is, again, I've defined this previously, so I won't go into a lot of detail here, but it separates the bottom 25% from the top 75%. The median separates the bottom 50% with the top 50%. And the third quartile separates the top 75% with separates the bottom 75% with the top 25%. Now, a caution I've added in here, depending on the statistical software package, the values for Q1, well, Q2 will always agree, but the value for Q1 and Q3 may not agree. And we'll get into something called percentiles once we get into normal distributions. We'll find out that there's not a universal agreement on how to actually calculate those either. So what you'll be expected to do in terms of calculating quartiles is to report the ones that are calculated from StatCrunch. All right, so just a little review, the interquartile range. IQR is just Q3 minus Q1. There's something called a semi-interquartile range, which is just Q3 minus Q1 divided by 2. And then we have a mid-quartile range, which is just the average of the two. So Q1 plus Q3 divided by 2. 5-number summary consists of 5 values: the min, the max, Q1, the median, and Q3. So if I ask you to report the 5 numbers, you're going to give me 5 values, these values. Now, finding the 5-number summary, I'm going to use what's called the Space Mountain wait times. I think this is actually for the 10 a.m. data set. And you can see that the data are already placed in order. So the first thing I would want to do is come to the center. No, actually, the first thing I'd want to do is just identify the 2 that are easiest to get, and that would be the min and the max. So the min in this case is 10 minutes. The max in this case is 110. I've been to Space Mountain 2 or 3 times. I think that 110 must have been me because I felt like I waited forever. It's actually closed one year we were there, but another year we were there, it seemed like we waited forever. Next thing I'd want to do is find Q3. Find the median, Q2, and I just come to the center. I have a data set with an even number, so I'd have to take the average of the 2 center values. It's pretty easy in this case because it's just 35. The next thing I do, let's focus in on how that 25 was calculated. The 25 is just Q1. It just turns out to be the median of the data below the median. So if I take my 35 right here, let's see if I can, so right there, all these numbers below, I find the median of those numbers, and it's 25. Start here again. I've got a bunch of numbers above. Find the median of the numbers above the median. That's called Q3. So therefore, the 5-number summary for the wait times of Space Mountain would be 10, 25, 35, 50, and 110. Again, respective of the low value, the Q1, the median, the Q3, and the high value. Now, once we get our 5-number summary, it is reasonable to create what's called a box plot. And there are a bunch of words there that explain how you create a box plot. I think it's going to be much easier to get a visual on this, which I have on the next page. So the procedure, calculate the 5-number summary. I go in and make dots at those 5 numbers, and I connect the 3 center dots with a box and then extend horizontal lines out to the min and the max. So just like this. So if I were going to make this, the very first thing I've got to do, and this is something you really need on your radar, is the first thing you do is you create your axis. Before you even start drawing points, you create your axis. So I know that my values range from 10 to 110. So I would probably go from about maybe 0 to 120. And mark these off in lengths that are proportional to each other. Next thing I would do is I would come in at 10 and I would make a dot. I would come at 25, I would make a dot. Come to 35, I'd make a dot. 50, make a dot. 110, make a dot. And then I would connect the 3 middle dots with the box, and then the so-called whiskers, or the horizontal lines that extend left and right, extend those out to the min and the max. Now, in complete transparency, I would never construct a box plot like this. I think when I think of a box plot, I think of 2 features that are important. First of all, display the 5-number summary. Secondly, display outliers. And this box plot does not represent outliers, which I think is one of the key important features. So before we get into outliers and box plots and outliers, let's think a little bit about the correspondence between a histogram and a box plot, because we can see a lot of similarities. If we look at the skewed distribution right here, we can see that we have a right skewed distribution. So for the box plot, I would expect this line that I'm tracing to be longer. If I have a symmetric distribution, then I'm expecting the left line and the right line to be about the same. And we get into something called a uniform distribution. That just tells me that the height of all the bars are just about the same. It's still a symmetric distribution, so I would expect these tails on each side, so the one I'm drawing here and the one I'm drawing up here, to be about the same length. So you can often easily match a box plot with a given histogram. For example, if I had a negatively skewed or a left skewed distribution, then I would expect this tail that I'm circling down in the bottom left to be much longer than this tail. All right. So identifying outliers for box plots. The very first thing we do is we find the quartiles. And for the Space Mountain data set, the quartiles are 25, 35, and 50. The next thing we do is we evaluate the function 1.5 times the IQR. So for our problem, the IQR is Q3 minus Q1, 50 minus 25, which is 25. So the 1.5 times the IQR would be 1.5 times 25, which is 37.5. Now, a data value is an outlier if the amount greater than 1.5 times the IQR above Q3, or we have a value 1.5 times IQR below Q1. So I can easily find those cutoffs by taking Q3 plus the 1.5 times the IQR, so in this case that's going to be 50, plus 37.5, If I have a value that's above 87.5, then it's an outlier. Take Q1, which in our problem is 25, multiply again the 1.5 times the IQR, subtract 37.5, we get negative 12.5. Doesn't really apply for this data set, but because we're talking about wait times, I don't think you can ride Space Mountain before you wait. It's kind of silly. So negative values don't appeal to us in this problem. So do I have anything above 87.5? Well, it turns out I do. I have two values, 105 and 110. So what I did is I grabbed the Space Mountain data set, calculated a box plot using StatCrunch. And what you'll see is you'll see out here where I'm circling, okay? You'll see two dots. Well, these dots that aren't connected to the box plot represent the outliers. So I can come down to the axis and see that's about 105. We know that because we have the data set. And I can come directly down to the axis and see that that's about 110. So I can approximate the outliers even if I didn't. I didn't want to do that. Even if we didn't have the data set. Now, what's this value right here represent? Well, if I scroll all the way down, I can see that this is about, what, 75, maybe? Something close to that. So this 75 wait time, 75 minutes in wait time is the highest value in our data set that is not yet an outlier. These two are unusually high compared to the other wait times. This one is not. So we extend the horizontal line out to the highest number in our data set that is not classified as an outlier. Again, these two are outliers. All right, gang, that's all I got.